Hi again, everybody. Chris Tisdale here. Thank you for tuning in. In this video, I'm going to continue my series on geometry with a circle arc template and a special tool called a Noesis straight edge. And part of the motivation for this video is in a comment that I received. I showed how to use a special tool to trisect an angle. But in the video, the size of the angle was acute. And so there was a natural question from one of the viewers saying, well, what about the obtuse case? Can you trisect an angle that's bigger than 90 degrees but less than 180? And the answer is yes. It's something that I've thought about, and I thought, you know what, that comment is the perfect spark for me to post another video. Okay, so let me share my screen with you, and I can show you what's going on. All right, so here we have one of the tools that I've designed. It's called a Mathemat Constructor series. And you can see here we've got a circle arc template with a center point. And then over here, we've got what's called a Noesis straight edge. Now, a Noesis straight edge is a famous tool that has two marked points on it. Now, normally in geometry, we just have a straight edge like this where there's no markings. But to trisect an angle, we need a little bit more. Now, the distance between this point and this point is the same as the radius of our circle arc template. All right, so how do we do it? So let me draw a few things here, and we can see how to trisect this angle, this obtuse angle. Okay. So in a previous video, I showed how to trisect, say, this acute angle alpha. But what happens if we want to trisect the bigger angle? So let's call this, I don't know, 180 degrees minus alpha. Okay. Now, luckily for us, essentially it's the same construction as the trisection of the acute angle, but there's just an extra step on top. So let's run through the standard construction, and then I'll show you what's going on. All right, so let's start by trisecting alpha. All right, so I'm going to put my circle arc template at this vertex, and I'm going to draw an arc that intersects in three places. So 1, 2, 3. All right, the next step is to use our Noesis straight edge in an interesting way. Okay, so I'm going to take my straight edge. Oh, and I might need to extend this line a little bit. So let me just extend this line a little bit. I can do that. Okay, hopefully that's still in the shot. Yes. Okay, so I'm going to take my Noesis straight edge, and I'm going to place it here, and then I'm going to move it so the R and the P touch the arc and the line down there. So see the P's lined up there, the R's lined up there, and I've got the rest of the straight edge lined up there. Okay, a little bit of back and forth is required. Okay, now this angle here is 1/3 of alpha. Okay, so that's the standard construction. Okay, So how do we do the trisection of this bigger angle? Well, we can kind of look at it like this. If we want 1/3 of this bigger angle, right? We just know that, okay, it's going to be 60 minus alpha on 3, 60 degrees. Okay, now this angle here is alpha on 3. So what we want is an angle of 60 degrees, and we would take away the alpha on 3. So do we know any triangles that have angles 60 degrees? Yes, we do. The equilateral triangle. Okay, in an equilateral triangle, all the angles are equal to 60. So let's construct an equilateral triangle in a suitable spot. Okay, so I'll use, what shall I use? I'll use blue. Okay, so if I can have an angle here, say 60 degrees, then the difference is going to be exactly that. So let's just refresh our memory on how you construct an angle of 60 degrees. You'll do one arc like that, get a new point, another arc like this, and then we will join this vertex with that point. Okay, so now this angle is going to be 60. So this angle is going to be 60 degrees minus on 3, which is the trisection of that angle. Okay. So, not too hard, right? It relies on stuff we already know, and we're sort of putting in an extra step whereby we want to construct an equilateral triangle in the right place. So let me just write a heading down there so we know what we're doing. So trisect obtuse angle. That's the idea. Okay. All right. So shall we give it a little test and see what how close we are? I think that's a good idea. So let's go in here with my, now of course you're not allowed to measure in geometry, but we can still do that. Okay, so this looks like it's about 126, 128 maybe. So this smaller angle should be about 1/3 of that. So around about 43. Let's see. Let's see what happens. Yep. Do it over here. Hey, look at that. That's pretty close. That's pretty close. Okay. So not exactly accurate, but pretty close. All right, folks. Of course, like this tool is special. You can't trisect angles with a straight edge and a compass. It's shown to be impossible. But this Neus's straight edge gives you a way of doing it. Anyway, what do you think? Are there other tools for trisecting angles? Let me know. If you have any comments, any questions, put them in the comments. And thanks for watching. Bye, everyone. See you.